Hi, I'm Nassim and I'm ESR for MANTEL Project Free and finishing my PhD in Estonian University of Life Science and University of Barcelona, and I'm presenting my secondment project in University of Barcelona entitled Numerical Modeling of the Role of Advective Flux in diel oxygen variation for estimating whole lake metabolism, which supervised by B.L. Obrador and with the contribution of my other supervisors, Rafa, Marcia, and Alulas, and hopefully will be submitted soon for the publication. So today I'm gonna be talking about how lake metabolism estimation is impacted by horizontal advection diffusion related to water movement. So a little bit of background, lake metabolism is the balance between carbon fixation or gross primary production and ecosystem respiration or biological carbon oxidation that create and consume organic matter. This balance provides you net ecosystem productivity, which is an excellent indicator of the lake trophic state. And whole lake metabolism is a measure of the fixation and oxidation of carbon from all organisms, including fish, bacteria, phytoplankton, whatever creature is in the lake. Hence, despite the small area that lakes occupied in the globe, their vital role as an important source of greenhouse gases to the atmosphere is undeniable. Therefore, it's essential to understand variation of lake metabolism and what's controlling lake metabolism. A simple diagram, you can see dissolved organic carbon gets respired and broken into inorganic carbon. Also, the key role of the light as a source of required energy for this process. So there's a lot going on that metabolism is essential to understand, like the dynamic of lake system. Okay, to answer the question of how episodic hydrometeorological disturbances, for example, related to change in wind speed, etc., are affecting lake metabolism, first, we need to improve the accuracy of the lake metabolism measuring methods. And in this work, I'm addressing the impact of horizontal advective mixing on open water measurements of lake metabolism, so far often ignored. So to study this, the experimental dataset consisted of independent DO, dissolved oxygen time series from free station in a water reservoir along the dominant wind direction, together with direct water velocity data from an acoustic Doppler current profiler ADCP, and the water velocity was used to feed a numerical model to estimate the next 10-minute dissolved oxygen concentration at the central station related to the horizontal advection and diffusion caused by water movement to determine their role in DO dynamics. So this is all just about testing the numerical model with real data to make understand the variation of dissolved oxygen measurement caused by horizontal advection diffusion and its effect in lake metabolism measurement. And it hasn't been done yet, so there are some limitations related to the testing with this real data because, for example, among 3 months' data, we were able to just use a few days, around 12 days, to avoid gap and missing data that would cause a significant error in the model. Therefore, if we had a bit longer and more accurate data set with a bit of the strongest effect of, for example, wind, it would allow us to tell a more accurate story. And you can see the distribution of missing data for each buoy and the huge gap in the data for example, for buoy B2. However, we used 12 days from February 16 to 28 for each 10 minutes from Sao Reservoir in Spain, around 1,700 28 points and almost calm days with maximum wind speed of 4 meters per second. Well, this is a day example from our results, and the black line is showing the diel concentration related to observed data corrected by gas exchange with the atmosphere, while the green line shows the dissolved oxygen concentration corrected by atmospheric exchange flux and horizontal advection diffusion for the central station. On the other side, it shows the wind speed graph, so it indicates almost calm weather that wind speed pattern is changing up to 2 meters per second. Also on the right side, diel concentration for free stations or buoys, which presented in previous slides related to our experimental design. And considering water movement from B2, buoy number 2 to buoy number 1, and the black line, which is the central station, also you can see the minor difference between them, and that would affect the result of predicting diel concentration for the central point for the next time step. Which we calculated it based on our numerical modeling. So it's not a surprise to see the minor effect of horizontal advection diffusion in diel concentration. And here we assess the effect of horizontal advection and diffusion and subsequent estimates of metabolic parameters at the central station using standard light-dependent metabolic models in a Bayesian framework. And it also shows almost no differences in rates in GPP, R, and NEP after correcting related to horizontal advection diffusion. And here we are using the smoothing function 1R moving average to remove the difference in the standard deviation between the corrected and uncorrected version of metabolism estimates, and it shows that we decrease the difference between corrected and uncorrected NEP after using moving average. And following the result of PI curves for the same day, with applying 1R moving average, which still shows a minor difference between corrected and uncorrected diel pattern. And summary graph with daily smooth rate, NEP, GPP, and R, with no significant difference in rates after correcting as well. So here to compare the expected predictive error between corrected version and uncorrected version, we use DIC, which is similar to AIC and is related to Bayesian method, and it's a combining measure of goodness of fit and measure of complexity based on the deviance. And the result shows because DIC, the lower and negative is better, so the result shows surprisingly we couldn't improve the accuracy of the model after correction, but it doesn't mean that this is the model is worse or better. Okay, to sum up, the result of our study shows the insignificant effect of horizontal advection diffusion related to water movement in this short period of our case study in Sao Reservoir in Spain, but we introduced appropriate numerical modeling and experimental design for future studies to get a clear conclusion associated with these questions, that what is the role of advective water movement in diel variability of dissolved oxygen concentration to metabolism estimates, for example, what is the noise to signal ratio and to what threshold the effect of horizontal fluxes can be neglected to avoid miscalculation of lake metabolism. And it would be interesting work for our future study to improve the lake metabolism model.